At a time. And ladies and gentlemen, welcome, boys and girls, math fans of all ages. Today we're talking about applying trigonometric functions, and that means we're solving right triangles is often what that means. So I'm just going to jump right into a problem. And when I say to solve a solve a triangle, I mean give me all other information that we can about the triangle. So if I know two sides and an angle, I'm looking for the other side and the other two angles. All right, there's 6 facts about any given triangle that I want to know, which is the 3 angles and the 3 sides. Okay? So if I'm solving a triangle, let's see if I can really throw you guys off with one of these ones.
Stop. Don't.
Well, just the
Dude, not cool.
direction
Not
that
cool,
this
dude.
is. Yeah, it's just sometimes people get thrown off when the angle's slightly different. So let's see if this is angle A, this is angle B, this is angle C. Suppose angle A
That's a pretty good British accent.
was, I don't know, maybe this is 38 degrees. Okay? And suppose I know that side little b is 4. Okay? I want to find out everything else about this triangle. I want to point out I know 3 facts about it. I know 90 degrees, I know 38 degrees, and I know one of those sides is 4. Specifically, I know exactly which leg is 4. So let's say I want to find out what is the length of side A. Okay, so here's little a, here's little c. How could I find side A? The way I'm going to do that is relate it to the information I already know. So how could I relate side A, side B, and this 38 degree angle? What's a relationship that compares those 3 things? Tangent, right? Side A is the opposite from 38 degrees perspective, and 4 is the adjacent, right? So the trig ratio that compares opposite and adjacent is tangent. So I'm going to write an equation. I'm going to say that tangent of a 38 degree angle would equal A over 4. And now how could I solve for A? A is currently being divided by 4. So I would multiply both sides by 4. Aha! So A is directly equal to 4 times the tan of 38 degrees, which I can get an estimate on my calculator, which actually a couple things I want to point out. Here, clear, come on. I'm going to hit mode. Make sure I'm in degree mode rather than radian mode. Okay, so there's 2 different ways of measuring angles. We're using degree right now. So I'm going to hit second quit out of that. So I'm going to do 4 times tan of 38. And I technically should close this parentheses, but in that current form it also would have worked anyway. And I hit enter, and I get 3.125. So A is about 3.125. And now, does that seem to make sense? Go highlight the degree mode and hit enter on it. The other thing you could do is I gave you the trig table the other day. You could look up 38 degrees. I think I gave you sine and cosine on that table. I don't think tangent was there. But you could divide the sine value by the cosine, since tangent is sine over cos. There you go. That would also work. And I want to point out that notice 3.125, that seems reasonable, right, in terms of scale compared to the 4, right? So it seems to make sense. Now, what if I want to find out what is side C going to equal? I would want to relate this to the stuff that I know already. So I'm going to relate it to these 2. Technically, I could relate it to this and this, right? I could do opposite over hypotenuse, but I'd rather relate it to one of the sides I was given rather than to the one I just found. Because what if I got this completely wrong, and now I'm building further information off of that knowledge? Yeah, it would just keep the wrong spreading like a disease through the rest of the problem, and that wouldn't be good. So C is the hypotenuse here. So what trig ratio compares my adjacent with my hypotenuse? Cosine of 38 degrees is equal to adjacent, which is 4, over the hypotenuse, which is C. In this case, sometimes they'll be labeled with like different variables and such. So how could I solve for C? This is a little bit tricky. You could reciprocate both sides. Sometimes I'll first multiply both sides by C. I think that's what I'll do this time. And I'll get C times the cosine of 38 is equal to 4. And then how do I get C by itself now? Divide
by C
by the cosine of 38.
Oh.
Cosine 38, remember, is just some number. All right? You could look it up on your chart. You could type it into a calculator. And it's the same number all the time throughout all the universe. So C is equal to 4 divided by cosine 38. So I'm going to do 4 divided by cosine of 38. So notice it isn't multiplication this time. I get 5.076. 5.076 is what I end up getting. And C is technically approximately equal to that, because I used an abbreviated version of it. And I want to point out, sometimes if I did do this wrong, what if I accidentally said 4 times the cosine of 38? And I hit enter, and I got 3.15. Would that make sense according to the sketch? Why? Yeah, the hypotenuse can't be smaller than my other dimensions, right? So you should always kind of do a reasonability check after you find your answer. And then the other thing I want to point out is that the largest angle, or 90 degrees, is always opposite the largest side. Okay? The smallest angle will always be opposite the smallest side, and the mediumest angle will always be opposite the medium side. All right, so there's kind of a nice little relationship between all those. Now there's one more piece of information I need to know. I need to figure out what is angle B equal to. Any ideas?
Oh my god, there's so much work.
Yeah, angles A and B are complementary to one another. So I'll do 90 minus A. So what's that going to be? 47, is it? No. 52. What am I saying? I was off by 5. So B is 52 degrees. And notice that's my medium angle, right? And that is opposite my medium length side. Okay? So the idea is find a relationship that relates that particular combination of sides you have. Tell me what it is, and then solve for the missing part. That's the idea. Es el idea. So, let's see. I want to at least introduce this one other example.
Blah.
Terrible. No. Let's see. Let's do this old trick. Oh, man. And I'm never going to go back and edit that. That's fine. Just fine. Let's see. Example. How about this? Find the height of the mountain. So guys, check this out. I'm going to draw a little picture here for us. Here's this mountain.
Is that Mount Snow?
I don't know. It's like a scary ice castle mountain right here.
Haystack.
Yeah. And here's a spooky cave.
Is that where the bear lives?
Maybe. That's true. So suppose, all right, I'm trying to estimate the height of this mountain, right? And the height is assumed to be measured perpendicular to, right, horizontal. And let's say that many, many, ways away, perhaps even miles,
There's a pond.
I'm looking up at this mountain, and I find out that at 37 degrees, 46 minutes.
Okay, how do you know? There's just no way you.
I would use like a little, darn, I just forgot that a sextant would work.
Mr. Waddy.
Yes.
Ew.
Also, a surveying tool would also work. I forget what those are called. But they've got like little plumb bob on them. You know what I'm saying. And then let's say that from this location, all right, I look up at the mountain and I find an angle of 37 degrees 46 minutes. I think I said seconds earlier. And then I walk forward 1,000 feet. Actually, I'm going to label this feet so it doesn't look like minutes. That's inconvenient. And I take another angle measure. All right, so this angle is different than that one. And this angle is 40 degrees 30 minutes.
No, I think it's more like 44.
Okay? And the question is, how tall is the mountain?
Would you just, add them both together?
What color is the bear?
What color is the bear? Yes. Now, one thing I want to point out is this dimension right here is, right from here to this is x. And I would not be able to measure that effectively unless I was able to tunnel into the mountain to the center and figure out how far that was. So that's not a measurement I'm finding anytime soon. At least not by hand. Well, not with tools and measuring tape or whatever. So check this out. I want to find the height. And what I'm going to do, I've got two separate triangles here. All right. So from this angle's perspective, this height is the opposite side, and x is the adjacent. So what trig ratio compares opposite and adjacent? TOA, tangent. So I'm going to say that tangent of 40 degrees 30 minutes, or 40.5 degrees, I guess, is equal to h over x, right? Now let's write another equation from the 37 degree angle's perspective. But in order to do that, I'm going to need to know what this entire length is. How long is this? X plus 1,000. 1,000x would be if I was 1,000 x's away, which would be much further. But now, so question from 37 degrees perspective, that still happens to be the opposite, and this whole thing happens to still be the adjacent. So that's going to be tangent of 37 degrees, 46 minutes. I keep saying seconds. And what would that equal? Opposite is h over x plus 1,000. And notice this, I happen to have two equations and two unknowns. So I could actually solve this as a system of equations.
Love that.
All right, but we don't have time to do this, sadly, right now, because class is just about over. But I just want to point out, well, actually, I would multiply both sides by x plus a hundo. 1,000. Actually, that's 1,000, isn't it?
1 million.
Tan 37 degrees, 46 minutes equals h. If this over here, I multiply both sides by x, I would get x times tan of 40 degrees, 30 minutes equals h. And then, since both of these are equal to h, I could set them equal to one another, right? And I could solve for x, and then I could plug that in and solve for h. So it'd just be a matter of kind of doing some substitution and stuff like that, which you guys are all masters at, of course. Of course. So, anyways, I think we're all set. So goodbye, Internet. Stay out of the icy cave. You've been warned.